Hello everyone, here's number 5 from the applied problems that I collected, worked out. So again, I'm just going to read it over. Please make sure you pay attention to everything I'm writing out here. This is what you'll be expected to do for the upcoming test. So number 5 says a rectangular garden is to be enclosed with a fence. One side of the garden will be a stream and will require no fence. So just like number 4 that had the barn, we have this side that we have the stream, and then our rectangular garden is going to go on over here. It says if the gardener has 125 feet of fence, what should be the dimensions of the garden that makes the garden with the largest area, and what will that largest area be? So again, everything could be represented in our picture. We're going to call the two shorter equal sides x, and then this length right here is how much fencing is left. So we started with 125 and we used up 2 x's, so it's 125 minus 2x, and that says it all just in that picture. So next we want to say that area, or A of x, is going to equal length times width. So we do x times the quantity 125 minus 2x. So if we distributed the x, we would get a quadratic. And again, between numbers 4 and 5, this will graph a parabola that opens down. So we're looking for the vertex here, which is the height. So we want to maximize area. So the ordered pair that you get, and again, you have to take some time to adjust your screen, but you should get 31.25 and then 1953.125. So we would say the max area is 1953.125 square feet when the width, which is x, so we would say when the width is the 31.25 feet, and we still have to calculate the length, so we just have to substitute in the 31.25 right here, and we say and the length, and yes, you could use a calculator on that. Just do 125 minus 2 times 31.25, and then you get 62.5 feet. And that's all there is to it. Like I said, the most difficult part is once you type this into Desmos, you have to adjust your screen a little bit. All right, now let's take a look at number 9. Here we are trying to minimize cost. What's nice though is it gives us the function. So here's our cost function. And as you type this into Desmos, just double check everything. It's 2.5 x cubed minus 12.5 x squared plus 10.1 x plus 52. Even though as I said it and I wrote it, I'm still going to double check it. 2.5 x cubed minus 12.5 x squared plus 10.1 x plus 52. So you graph this. And again, you need to kind of adjust your screen if necessary, but you get something that looks like this. And we are after this point right here. We're trying to minimize cost. So the ordered pair you get here is 2.863 and 37.125. But what it tells us is that C is the cost in thousands of dollars and X is in hundreds of parts produced. Find the number of parts produced to the nearest whole number and the corresponding cost to the nearest dollar that makes the least cost. So we need to take this number and multiply it by 1,000, and this is the minimum cost. This number needs to get multiplied by 100, and that's the number of parts. So the way we answer this is that the least cost, or the minimum cost, is the amount of money times 1,000. So this is going to give us $sign here, $37,125 when, if we multiplied this, the first number, 2.863, by 100, we're going to get a 286.3. Rounded to the nearest whole part would be 286 parts are produced. So that's how we want to do a minimizing cost function problem all the time. So of the problems that we went over yesterday, which was 3, 4, and now 5 and 9, you only have 3 types. Number 3 was a volume problem, so study how to do that one. All the volume problems are going to be done the same way. The only difference is the number, like the 20, is going to change. The area problems like 4 and 5 are always going to be set up this way. What's going to change? Whatever this first number is. It was 100 in number 4, it's 125 now. Everything else stays the same. The cost functions, they give you the cost function. The process still stays the same. We're trying to find this ordered pair right here. We write out that ordered pair, but then we interpret it. So again, make sure you know how to do these problems.